Hi, this is Nimla Rednam. In this video, we are going to look at long division method, which is the method used to find the square root of a given number. Now, in the previous video, we looked at prime factorization as a method to find the square root of a given number. Now, when the number is very large, prime factorization becomes very lengthy, and that is where long division is a more appropriate method to find the square root. So before going into the details of the method, long division method, I want to discuss about the possible number of digits in the square root of a given square number. Okay. So in order to do that, what we are going to do is list down the one digit numbers and their square roots. So one digit numbers start with 1, 1 square is equal to 1, right? And what is the largest one digit number? 9, right? And 9 square is equal to 81. Okay. Now here, next I'm going to consider the two digit numbers. Two digit numbers start with 10. 10 square happens to be 100, right? And what is the largest two digit number? 99. So I want to find 99 square. Either I can multiply 99 by 99 in order to find this, or if you remember, we looked at some other methods. I want to use the algebraic expansion of this. Okay, this is very easy. You know that a minus b whole square is a square minus 2ab plus b square, and here the calculation becomes much easier when you do this. So minus 2ab plus b square. Okay, so from 10,001, I have to subtract 200. So what is it going to be? 9,801. So that is my 99 square. Next, I want to look at three digit numbers. Three digit numbers start with 100. So 100 square, in just a moment, you'll understand why we are doing this. 100 square is, you'll have 4 digits, which is nothing but 10,000. And if you look at the largest three digit number, which is 999, and we are going to look at the square of this. Again, I want to use the same method. So 999 is nothing but 1000 minus 1. So if I want to square that, again expand a minus b whole square, I'll have 6 zeros in 1000 square minus 2ab plus b square. So I am going to subtract. Okay, I want 1 here, right? I have 5 zeros and a 1, and from that I have to subtract 2000, right? Okay. So here I have 1, 9, and then I have, so this here is 0, sorry, it's not 9. 1 minus 0 is 1, 0 minus 0 is 0. Again, I have a 0 in hundreds place, and here I have a 8, and then a 9 here and a 9 here, right? So I will have 998001. Okay, so that is my 999 square. In fact, you can see that there's a pattern emerging here. Like in the first exercise, we looked at few patterns with the squares for, 1 square, 11 square, 111 square. Similarly, there's a pattern here. You can actually deduce the pattern. Anyways, so we are interested in the number of digits. So you can see here that for one digit numbers, the square is going to have either 1 or 2 digits. How do I know that? Because I have taken the least and the greatest one digit numbers. So everything in between is going to have either 1 or 2 digits in the perfect square, right? Because I have 1 digit and 2 digits. That means in between any number, if you square it, it's going to have either 1 or 2 digits. Now here, if I take a 2 digit number, okay, the square is going to have 3 or 4 digits. And if I have a 3 digit number, the square is going to have, if you count, this is 5, and over here it is 6 digits. So the square of a 3 digit number is either 5 or 6 digits, right? So there are a few questions they have asked in terms of what is the, what is the number of digits, what are the number of digits in the square root of a given number. So for that we are trying to deduce a formula here. So let's see how we are going to do that. So I can say that if the given number is a 2-digit number, if the given perfect square is having 2 digits, then the square root is going to have half of it, which is 1. Okay, there it is easy. I'm going to get the formula as n by 2, right? But what about this odd number? Okay, let me check the even one for everything. Here when I have 4, half of it is 2. And I have 6 here, so half of it is 3. So no problem. Whenever I'm having an even number given to me and they're saying that find the number of digits in the square root of this number, I'm simply going to say n by 2. What about the odd digits? What we are going to do is, even for 1, the square root is going to be 1. For 3 also the square root is 2. For 5 the square root is 3. How do I get that? If it is odd, you simply add 1 to it, make it even, and then divide it by 2. So this is our formula. So this is how we are going to check for the number of digits in the square root of the given digit, simply by counting the number of digits in the given number. Okay. So this is about the number of digits. Okay. Now let us look at the long division method. So what we are going to do here is, we will be pairing the number into groups of 2. Okay, we are going to be pairing it starting from the ones digit. So here when I have, let me show you the textbook. This is the first example that they have given, 529. Let us find the square root step by step so that you will understand the method of long division. Okay. So here what we are going to do is, let's take the number 529. Okay. The first step that we are going to do is pairing the digits starting from the ones place. Okay. So now I have paired these two. Now I have only one digit left. No problem. I'm going to pair it. Imagine a 0 to the left of it. It doesn't change the value of the number. So I'm going to call it pairing. Right. And then consider the first bar. Okay. First bar, what is the number I have? I have a 5. So I have to check what is the closest perfect square, right? What is the closest perfect square to the given number under the bar? So the number here is 5, and you know that 4 is the closest one, right? 5 lies between 4 and 9, the two perfect numbers, right? So 4 is nothing but 2 into 2. So 2 2s is 4. Now as in the usual division, I'm going to subtract these two, I'll get 1. And then take down the entire number you have under the bar. Okay? Not one digit, I'm going to take both the digits, right? Now here, the next step what you're going to do is, so the second step here was finding the nearest perfect square. Nearest perfect square, that is less than the given number under the bar. Nearest perfect square, right? So what is the next step? I'm going to take the double of this or multiply these two. 2 into 2 is 4, right? Now I don't know the next digit here. Okay. And I want to find the digit over here such that when I multiply it with that new digit I have, this is the closest number to the given the number we have of our interest, which is 129 in this case. Okay. So if you check 41 into 1, it is too far away. Next I'm going to check 42 into 2. Okay. This might be the case, but again let us confirm. Let's check 43 into 3. Okay, this happens to be exactly this number. Need not be exactly the number. If it is not a perfect square, you will get something closer to it, and we're going to take that and we'll be left with some remainder, right? So here I have 3. So here in the quotient I'm going to write 3, and here I'm going to write another 3, and I have 129. So that is it. This is my square root of 529, which is 23. So square root of 529 is 23. If you remember in the previous exercise, we were using prime factorization, and 529 we used prime factorization. The video that I uploaded with all the remaining sums was a previous video. Over there I couldn't explain actually, but when we had a sum which had 529, and when we were using prime factorization for it, it so happens that you checked every prime number up till 23. So when you are trying to do that in exam, you might, for now you know that 23 square is 529, it's noted to you. But usually that's the advantage of long division over prime factorization, that sometimes it so happens that for any prime number, when you take the square of it, 29 square and so on, you'll be checking for every prime number up till then, and that is going to become very time consuming for you. In those cases, long division is going to be, you can actually compare, do 529 with the prime factorization and immediately do it, time it, and you will see that not probably 529 because you already know the answer, but some other perfect square which is a square of a large prime number. Then you will understand how long division is definitely more useful than prime factorization, right? So this is about the long division method. And here, because this is a 3-digit number, as you can see here, 3-digit number, so the square root is only 2 digits, 3 plus 1 by 2, 2 digits, so only in 2 steps we got the answer. Now if you have 5 or 6 digits, then you are going to have 3 steps for your in order to get the answer, right? So if and when we come across a 5-digit number, I'm going to explain the 3 steps that we have. As of now, we are having only 2 steps, right? So that is about long division method. Here again I have 4096, which is again only 2 steps because it's a 4-digit number. Okay. Now, estimating the number of digits in the square root, like I told you, it is simply you will be looking at the number of digits in the given number and you will be able to conclude, right? So here they've asked what is the number of digits in the square root. Without calculation, they want us to find out. Okay, so here you know that I have 1, 2, 3, 4, 5. So 5 plus 1 by 2, 3 is the number of digits in the square. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 1 by 2 is 5. So you can either do that or count the number of bars. Okay, 5 is the number of digits in the square root. Here again I have 3 bars, or you can say 5 plus 1 by 2 is 3. So 3 is the number of digits in the square root, right? So this is how you are going to do the estimate the number of digits in the square root of a given number. Again, they have given 2 more examples. Again, you have 3-digit, 4-digit. So in 2 steps, you are going to get the answer. Now look at this word problem here. They're asking you find the least number that must be subtracted to make it a perfect square. So here, what we're going to do is, if you remember, in the previous exercise we had find the least number which should be divided or multiplied by the given number to make it a perfect square. When they ask you in the question, when they ask you the number that has to be multiplied or divided, prime factorization has to be done, because that is where you're going to write the number as a product of prime factors, and that is what is going to help you in arriving at the answer. Whereas here, when they're asking you about adding or subtracting, here they're talking about subtracting. Here prime factorization is not going to help. Here what you need to do is, you have to do long division. So if you look at these steps, you will see that 56 is closest to 49. So 7 square 49. 7 plus 7 is 14. And then the third digit they have checked, it happens to be 4. 144 into 4 is 576, right? And so you're going to get the difference as 131. Therefore, 131 is the number that has to be subtracted from the given number to make it a perfect square, right? So in the explanation of the, one second, I just realized that here I use the term 2 into 2, that is to say double of 2. Okay, it's not that here you will have 7 into 7 and 9 into 9. Here, whatever is the digit, is the number you have here, you have to take double of it. Or another way to look at it is you take 2 plus 2, right? Or you say double of the number that you're getting over here, okay? So, yeah. So, they got the remainder as 131, which means that 131 has to be subtracted. Okay, so yes. Now let's look at the next question, the next solved example. They're saying find the greatest 4-digit number which is a perfect square. Now here in the beginning of this video we looked at the perfect squares of different 1-digit numbers, 2-digit numbers and so on, right? Now they're asking the perfect square is 4-digit number, right? And we have already seen that if it is a 4-digit number, then it is the square of a 2-digit number. Okay, let me take back to here. Can you see this? If it is a 4-digit number, then the square root is a 2-digit number. So if this perfect square is largest, greatest, that means this 2-digit number is greatest. And what is the greatest 2-digit number? 99, right? So 99 square is 9801 and this is my answer. This is the largest 4-digit perfect square. Understood? So here, as they have done, they have actually used long division. That is not required for this particular sum. You need not do this long division. You can directly say 99 square, right? Next question is, find the least number that must be added. Now earlier we subtracted the remainder, remember? Now we have to add to the given number so as to make it a perfect square, right? So now here what we are going to do is, we'll first do the long division and you have a remainder. What does this mean? If I subtract this 4 from the given number 1300, then I get 36 square, right? So I have 36 square, okay, and that means that the least number that must be added, if 36 square is less than 1300, what is the next perfect square? The next perfect square adjacent to 36 square is 37 square. Correct? Now 37 square is nothing but, you will have to find that square. Okay, you're going to do 37 into 37 and see that the answer is 1369, right? So if this is the next perfect square, that means what am I adding to 1300? I'm adding 69. So my answer is 69. Okay, so at the face of it, these questions, the number that has to be multiplied with the given number to make it a perfect square, or divided by, or subtracted or added, or what is the greatest 4-digit perfect square, 6-digit perfect square, so on. Though they are going to, you need to first understand clearly what they're asking, and then the calculation part is going to be very simple. First, you need to decide whether you're using prime factorization or you're going to use long division, and then proceed from there, right? So this is about square root of numbers. Next, we are going to look at square root of decimals. Now the method is exactly the same. The only difference, and the most important difference, is about the first step itself, which is where do you put the bars. For example, I have 17.64 here. Let's do this sum. I have 17.64, right? So I'm going to take a new page. 17.64, right? What we are going to do is, Now before the decimal, whatever is there, the way of the method of putting the bars is the same. Start from the ones digit and keep on pairing them, right? For the digits after the bar, you're going to start with the digit immediately next to the decimal and then do the pairing. Okay, so it is going to be in the opposite direction, right? Before the decimal, you're going to go in this direction, whereas after the decimal, you will be going in the opposite direction. Okay, so here I have 17.64. Okay, very little space for the quotient. Here the same method, right? So 16 is clearly the closest one. So I'm going to have 4 square 16. When I subtract, I get 1. Now here what am I going to write first? 4 plus 4. Okay, earlier I said 2 into 2. I hope it's not confusing. So I'm going to say 4 plus 4, right? So 4 plus 4 is 8. My quotient is, I guess now it's visible, yes. 4 plus 4 is 8, right? So I'm going to write 8 here and then we'll worry about this second digit. Okay, what about the quotient? Here my decimal is already there. So I have to put the decimal after this, right? And then I'm going to bring down 64, whatever is under the bar. Now, if you immediately you can see that 81 into 1 is 81, 82 into 2 is 164. So I have 2 here. Okay, so 82 into 2 is 164 and the remainder is 0. That means it's a perfect square. That means 4.2 square is nothing but 17.64. So that is how you're going to find the square root for decimals. Okay. Again, they have given one more example, 12.25. You're going to get 3.5. In fact, here you can actually answer this directly because when you have 5, we've already seen. When you have 25 in the square, okay, you've already, if you remember, in finding the square of a number ending with 5, you've seen that, for example, 35 square is nothing but 3 fourths 12, 25. Right, here you have to find the square root whenever you have 25. If you look at this and if you can clearly, you can immediately see that it's 3 into 4. So you know that it is 35 and there are 2 decimals here. So the square root will have 1 decimal. Okay, so that way you can even cross check, right? So that is about finding the square root of a decimal number, and then they have given a couple of word problems and then the exercise, right? 5.4. So here, if you can see that we have a lot of calculation sums, which I'm going to be uploading a similar video to the one I have uploaded for 5.3 because there's no explanation here as such. Okay, and it might become very lengthy if I explain each and every sum. And let's see, and maybe we will solve these word problems in a in this current format. But whereas these sums, the first question you have like 12 sums in long division method, maybe video just with the solution is going to be sufficient. Okay, so that's it for today's video.